So, for the survey, who has built a functional prototype? All right, that's awesome. Cool. Who has actually gotten that functional prototype onto the store shelves? Cool. Nice. And of those, has anybody sold over more than 5,000 of them? All right. That's awesome. Congrats. It's a really long and hard journey. Okay, so just a little background on Dragon and who we are. So I cut my teeth at iRobot and was really lucky to be in the right place at the right time. We had basically 12 different business units, from Lisp garbage collection to underwater acoustic modems to military robots to big floor cleaning robots to this little round thing that would clean your floors. And the reason we did that, and it wasn't so much part of the mission, but people kept coming to us and say, hey, can you build a robot that either brings me a beer or will clean our floor? And we ended up eventually doing both, but the voice of the customer came through loud and clear. So I had the opportunity to take that from a functional prototype stage and then figure out how to scale it. So going back and forth to great factories in China, figuring out how to select one, what the product should actually cost, how to put together a quality plan, and how to understand the schedule. And those are the things I'm going to talk to you about today. About 5 years ago, I left iRobot, which is a great company. On the good side, we went public. On the bad side, we became a public company, and that's less fun than being in a startup. So I left on great terms to do what I love. And we had the opportunity to start working with great Boston entrepreneurs like Ben Rubin, who's co-founder. Derek is over here from Zio. And basically scaled that up of acting as an API for manufacturing. So how do you go from the functional prototype to high volume production, which is something I'm passionate about. And as Christina said, we've been really lucky to work with Pebble, so we help them manufacture all of their watches, MakerBot, Siftio, Remotive, Orbotics, and about 100 others. So that's Dragon 1.0. I'm going to talk about Dragon 2.0 at the end of this. In terms of the way the product development paradigm is changing. So let's dive into it. The manufacturing triangle. There's basically three things to consider: the cost of goods sold, the quality, and the schedule. And the old joke is, you can pick two of the three, but you can't have all of them. In practice, it's really a matter of finding the right balance. So if you're building a medical device, you probably care a lot more about quality and a little bit less about cost. If you're building a consumer electronic product, you probably care actually a lot about all of them. But the challenge is finding that balance. And as we look at it, in our business, there's a lot of unknown unknowns. It's really hard to Google this stuff. You kind of have to learn from experience. So this is what I'd like to share with you as you think about scaling your product and your business. So let's start with cost. So COGS, or cost of goods sold, is basically just what does the thing cost. And it seems simple, but there's a few different ways that you can look at it. We typically deal with X factory or XF, which is what does the product cost at the loading dock, often in China, but it could be in the US or anywhere. You could also do freight on board. So to get that, you just take the X factory cost and add the overland transportation. That gets you freight on board. Then you could do landed costs. So let's say you build it in China, ship it to NTM, put it on a cannon over the Pacific for 4 weeks, and it lands in Port of Los Angeles. Then that's the landed cost. And then on top of that, if you warehouse it for a while, there'll be a cost associated with that. So as you think about the cost of goods sold, you want to figure out you want to talk about apples and apples, so you're comparing the same thing. So just understand where in the process you're looking at it. A critical thing to remember also is it doesn't include tooling. So you might, in some cases, amortize the cost of the tooling across the product. And just to give you an idea, if you're building injection molded tools, I think for the Roomba we had about $500,000 in tools. So these are really expensive things that you don't want to forget those costs, but they don't typically show up in the cost of goods sold. And the other thing to keep in mind with the COGS is that it varies with time. So you can imagine you're in a big rush, you launch your product, and then you learn a tremendous amount, and you want to make running changes, either to improve the quality or reduce the cost. Well, the recipe is going to change over time. So you want to figure out, what version are you talking about when you figure out the cost. And that's a whole science to keeping track of that stuff. Other variables are if you build in China, and it could be anywhere, but I'll just use China because I know that well. Obviously, the RMB floated in 2005, so the variation between the dollar and the RMB may change over time. The price of oil changes, which is going to affect how much it costs to get from over there to over here, and so on. So it does tend to move around a bit. Just in terms of putting the COGS in context with a really simple retail model. So the COGS is what you pay for the cost of goods from the factory. And then if you go through, say, Best Buy, you'll sell it in, you sell it to them at a certain price, and that delta is your margin. And then they're going to sell it to the end consumer. So we talk about sell in and sell through. What you ultimately care about is sell through, because you need people buying your product. Otherwise, it's just going to build up an inventory. But this is your money. And that's ideally you want 50 points, at least more is better. So what are the things that drive some of the cost of goods sold that you have control over? One is definitely your design. We were working with one entrepreneur that was building a product, and I think he had 14 different resins and 28 different tools. That's going to be a super expensive design. If you can get it to just ABS for your housings and maybe Delrin or Palm for your gears, that's going to be a lot less expensive design. Another one, which is my sort of personal pet peeve, is packaging. And I'm an engineer as opposed to a product designer. But the packaging drives the cost of it will drive sales. Like, great packaging is important. But it's something that gets thrown away at the end of the day. So if you can create equally compelling packaging that creates less landfill and less money wasted, if we can say that, that's a really good thing to do. In fact, I've had some clients that the packaging costs more than the thing. And it just seems like there's a fundamental flaw there. So if you want to shave money, and again, the money you shave is money in your pocket, which is money to go and do cool things, you can look at packaging. Another key one is pack out. So for example, and it's easy to use the Roomba because most people probably know what that is, you could have the robot and then a couple of virtual walls. Well, every virtual wall you pull out, that's the less COGS that you have to pay because there's less stuff in the box. So COGS is a really, really big deal. It won't seem it initially, but your business will depend on understanding this and getting it down. So you always want to drive it down as far as you can, but not lose quality. That's kind of the dance. In terms of other things like labor rate will make a big difference. So in China, the labor rate typically is $4 to $6 an hour. In the US, maybe it's $20 an hour. If you're designing a product for the US, you probably want to try to automate it so that you're not paying a lot for labor. If you build it in China, maybe you care a little bit less about the labor rate.
Have you seen that change a lot in China recently?
Oh, absolutely, yeah. 20% year on year is sort of the average growth. When I started, it was maybe $1 to $2 an hour, and we work with the upper end factories, so they're going to pay more than the government minimum just to maintain the workers. But yeah, every year it goes up, and that's a big concern. When people look at China, they're like, are you still going to be manufacturing there because it's getting so expensive? And it absolutely is growing exponentially. It's just often the labor is a small part of the overall cost of goods sold. But it's important because we see a lot of people don't include it in their BOM, and that's, if you're running a crowdfunding campaign, that's painful because you may not raise enough money. So you want to keep that in mind. Now, for your bill of materials, the whole trick in controlling cost is transparency. So I used to have this great picture of spam or mystery meat. You want no spam in your bill of materials. You want to know, so the thing you don't want is for a factory to come to you and say, this remote costs $5. That's totally useless for me. It doesn't tell me anything. What I want to know is exactly how much does the plastic cost, how much does the screw cost, how much does each capacitor cost. So just break it down as granular a level as you can. So these are my molecules. You got to understand it at that level. And the factory will always tuck a little bit of fat in everything because they know you don't have enough time to go and chase it. If you're Apple, of course, you can do that, but most people aren't Apple, so you've got to look at that. The other thing with the BOM is it always follows the 80-20 rule. So 80% of the cost is driven by 20% of the components. So don't waste your time on resistors. You get 10 for a penny. So if they charge you twice as much, who cares? But look at your processors, battery, memory, power adapters. Like, those big things are what you want to go chase. The other thing about the mechanics of a BOM is the way the factory makes money is on volume. So they might charge you a little NRE or non-recurring engineering, but they really want you to start selling in high volume. And they will apply a markup to every component within your BOM, including labor. So that's where they double dip. But let's say you have a processor, some sort of Atmel for $3.28. They're going to apply their markup, which for consumer electronics should be 15% to that. So what you want to keep in mind is that for a resistor, who cares if they charge 15%? But if I've got a $50 Telnet module, like a GSM module, I really don't want to pay 15% on that because they're not doing any more work than just plunking it down on the board and putting it through the reflow oven. So what we do is for every component more than a threshold, and that threshold is $1, we separate that in the bill of materials, just have a if this then that, put in a different column, and then apply a special markup to that. And that's something you'll negotiate. But that will save you a lot of money right off the bat, and it's not a lot of effort to do. You always want to compare to standards. So, and that's a little hard if you don't have a presence in, let's say you're building in China. But as many people as you can talk to, and we can always help you at Dragon as well. What are you paying for this? What are you paying for that? So that you make sure you're in the ballpark. And then you should also negotiate the inclusions. So are they including the test fixtures, the board setup fee, and all of that in their margin, or is that stuff that they're going to hit you afterwards? And that's another way you can beat down the cost of goods. So let's see. Just a reminder here, like every penny does count. Initially, you're probably pushing so hard for the schedule and quality. You might let a little bit slide, but eventually as your line gets more mature, you literally are going to go after the pennies. And just to make that case in point, for example, every part you mold is going to be on a certain tonnage machine. It might be a 50-ton press or a 200-ton press. The bigger the press, the higher the labor rate. A common trick of the factories, and it's not really a trick, it's just something that happens often, is that they're going to run your part on a bigger press than they need to. So you should go and look and make sure that they're running in as small a press as you can get by. And you can also time out, if it's a 30-second cycle time, figure out what the hourly rate is on the press and make sure that you're being charged the fair amount. So these are all things that get more important. But we've gone as far as like even weighing the glue to make sure that we're paying the right price. So just to make sure everybody's awake, how would I calculate labor? Any ideas? And this is always a place where the factory is going to add fat because they know nobody can calculate it. All right, so labor in China, you should try to figure out what labor is, but let's say it's $4 to $6 an hour. It's just a matter of literally going down to the line, counting the number of workers and counting the number of products that pop off the end of the line and doing the math. And that will give you the labor rate per product. But I guarantee they're going to shove a lot of extra fat in there. And then they apply to the markup to that anyhow, so they get to double dip. So that's a huge profit margin. Now, that said, we always want the factory to be making money. The factory is your partner. You don't want to beat them down, but you want them to charge you a fair price. If they're not making money and another customer comes in that is paying them money, they're going to drop you and work on the other guy. But in the same sense, you don't want to pay them too much money. So everything is a balance. We talked about no mystery meat. And then as you do usually go through this request for quote process. And the trick there is you want to look at 3 to 5 factories. You do 3 as a minimum so you get voting. So you probably don't have a giant database of what everything costs. But if you were to get 3, then you can see who the outlier is. You find the bottom guy and then use that as leverage to push the other guys down. And factories don't particularly like this, but it's an effective strategy. And the reason you might pick 5 is 2 of them may fall out. They may do a no bid or something like that. That's a little trick you can do there. And of course, leverage is good. The minute you sign on the line with a vendor, you're locked in until you're producing high volume. It's extremely disruptive to go and change CMs. And if you remember nothing else today, just remember the most important thing is picking a great factory. If you pick a good one, you can do anything. And there's many amazing factories out there. We have seen one case where a factory that was not a good factory was picked, and it pretty much killed the project. So you really want to spend a lot of time picking a great factory.
If you have good factories, do you take all your work there, or you think, okay, these guys are good for this kind of work? What's a good factory?
Right, so it depends on your volume. We recommend for low volume, which might be up to 5,000 a month, so not that much. Probably stick with one factory and build that relationship and that trust. And it helps certainly if you can have feet on the ground, and it doesn't matter where in the world they're located.
But for you, how do you find your factory?
Oh, yeah, so we've been doing it for a while. So we have a lot of great relationships with factories, some in the US, many in China. And then with our network, suppose, like I was talking to one person today who was interested in building a product with glass. I haven't done any of that, but we can crawl around with our network, and chances are we know somebody who knows somebody. And the trick with factories is you always want to visit the factory. Never work with a factory you haven't visited. You always want to be able to meet with the owner, because chances are you're probably a smaller client coming in, and the factories are going to have much bigger clients. If you can't sit down or pick up the phone and get the owner on the line to help you push your project through, you're going to get killed. And we sort of call that the fish in the pond, that you want to be the right size fish in the right size pond. And then also, there are amazing factories in China, and there's some that will turn your stomach. Looking with your own eyes, like usually through common sense, you can figure out if it's a good one or not. And then there's, with experience, you also know what to look for. But the most important thing is to pick a great factory.
How early in the design process do you engage with factories? Because most of us are in the prototype stage, so we're blind to what's going to happen at the other end.
Yeah, so I like to engage with a factory, let's say when the prototype is 80% complete. And by 80%, I mean that you've done the R&D, the thing basically works. We're not solving basic science or research projects. But you're not so far along that you've got all the drafts and rounds in the product, because every factory is different and every factory has different capabilities. And the trick is getting them involved in the design so they have buy-in. Factories are, this is weird, but factories are people. And it's all about human relationships. And if you get their engineers excited about what you're doing, they're going to be a lot more productive. And from a business standpoint, the factory is not trying to make money on the NRE. They're trying to make money on volume. So you can get a lot of mileage out of that. With that said, you should always pay NRE so that you make it very clear you own the IP if you ever did want to go to a different factory. And it also gives you an ability to push them. If you're not paying anything, then it's really hard to say, hey, we've got to meet this deadline. What's going on? But yeah, I love to get them involved. And the factories do this for a living, so they'll have a lot of really high value input.
Just back on the bomb for just a second.
Yeah.
How often do you find yourself, or do you find yourself recommending sourcing components yourself rather than letting the factory do it, like critical components, ICs, and things like that?
Right. So.
Repeat the question, please.
Yeah. So how often? The question was, how often do we find ourselves sourcing the individual components versus letting the factory do it? And what we recommend there is, assuming you're building a product with electrical, mechanical, and software, no matter where you build, you always want to protect your IP. Mechanical is easy to knock off with a laser scanner. Electrical is a little bit harder, but if somebody's motivated, they can X-ray it and figure out what components they're using. Software is both the easiest thing and the hardest thing to protect or to copy. If you send the code to your competitor, it's easy. But if you use a bootloader, which is basically a secure encryption in the code, and say you program that at Avnet, which is a special place in Hong Kong, not in China, where all the workers are scanned in and out, no pockets, no phones, basically secure, and then you consign that processor to the factory. Then you know exactly how many processors you ordered and how many products should come out. What happens is, and again, if you pick a good factory, it's never a problem. But if you had a bad factory, then they might build twice as many, and half of them go out the back door in a go shift. So that way you control it. Typically for more expensive components, you might want to consider consigning it because you'll get a lower margin. We talked about the standard margin, the special margin. The consigned margin is even lower because your argument there is it's not tying up their cash flow and it's not taking their cycles. So you can look at it. My recommendation is only consign one part because the factory does this for a living. And the problem is if you, like most of us, or many people don't do this for a living, and if you try to save money and consign everything, chances are you're not going to order one of the key ingredients, and if you don't have the ingredient, the product's not going to be built. So to save a little bit of money, you've shot yourself in the foot. So it's just that one component to control the IP. It's a great question, though. And as you get a bigger team and sewing, you can dive into different strategies.
What do you mean by consign?
Oh, sure. So consign would mean I might buy my processor. Let's say it's some sort of a ST Micro from, let's say, from Arrow. And then I own it. It's in my Dragon warehouse. And then I give it to the factory. The other way, the standard way, would be the factory would reach out to Arrow to buy the processor and bring it in. But if they do that, I never know how many they're buying. And if they were dishonest, they might, and I have a hot product, they might buy twice as many and then build twice as many products and sell half of them at night. So that way I know exactly how many are built.
Earlier you mentioned packaging. Do you expect the same factory to build the widget and put it in the attractive plastic thing that goes on the shelf?
Yes. So the factories we typically deal with are their final assemblers, and often it's really important they have SMT, or the machines, the robots that put the electrical components on the board, often injection molding, and then the final assembly and testing and quality. The other way to do it is you could source, say, plastic parts in China and ship them over here and put them together in the US.
No, I mean like the literal blister pack and cardboard and so forth that hangs on a package.
Yes. Yep, they should do all that. And typically you'd go in, we call that the gift box, and then that would go in a master carton. And that way they have ownership of it. So you would do a final inspection of the product after it's been assembled and then sign off that it's okay, that you accept it or you reject it. Yeah, and usually dealing with smaller companies, we want to keep everything as simple as possible. And some things, like just to pick on Apple, like they're so IP sensitive that they might work with 5 different factories in China and never give each one of them the whole recipe and then ship it over here and put it together. But if you think of it like the logistics of managing that as a small company, you'll drive yourself batty. So, cool, great questions, thank you. Yeah, oh, and leverage. So if you can, as we talked about with the RFQ, have a few factories to choose from, and it's really important that they know you have a few factories. You'll get them to do it. You probably, if you did, in the interest of time, just pick one. Just tell that one you're bidding it amongst other ones, because otherwise you'll lose your leverage. The anatomy of a bomb is super simple, and I've got an image of one later, but basically just an Excel file, and again, no mystery meat, so the sum of the parts. This is the order we usually do. So injection molded plastic, purchase parts would be like springs and things, electrical components, consigned we talked about, deco is either spray painting or tampo printing, the packaging, you never forget the labor, and then typically the markup we deal with is actually the sum of all this stuff, so their profit, the overhead, and the scrap. And they often won't break that one down. As you get into higher volume, you can actually say, hey, what's your scrap rate? They probably will bake in 2%, but if they're good, they'll get it down to 0.5% and keep the extra. It's not a bad thing, though, because you're building a higher quality product. So here I have a gear that I'm trying to build. It doesn't matter that it's a gear. And the answer is sort of yes and no. It's from a plastic injection molding standpoint, it makes no difference. It's a piece of plastic, and I'll show you how to calculate that. It doesn't matter if it's a gear, a housing, or something like that. From a tooling standpoint, it matters a lot that it's a gear, that you're going to set up your gates and runners and things like that very differently. Like you'd probably use a 3-plate mold for this, and there'll be no draft on the gear teeth. But just from a straight plastic standpoint, it makes no difference. So with this, you're going to be able to calculate any piece of plastic you see out there. And it's kind of a fun exercise to do. And you don't even need a factory to do this. So if you've got a housing or a SolidWorks or a Pro-E model, you can absolutely calculate what it's going to cost. Not from the tooling, but from the plastic. Part 1 is the material or the stuff. And it's basically just the weight of the part times the cost of the plastic. Now, the shot weight is going to be a little more than the weight of the part because you need plumbing to get the plastic through the sprue and down the runners and into the gate and into the cavity. But plastic is relatively cheap, so you could add 10% to the weight of your part, just to pick a number. And the second part is the machine overhead. So how much does it cost to run the press? And in the next slide, I'll tell you how much the presses cost. But basically figure out your cycle time. So if it's 30 seconds, what percentage of an hour is that, and how many dollars an hour does it cost to run the machine? Add them together and then multiply by the factory markup. And that's how much your plastic costs.
Where do you get the resin cost?
Oh, okay. That's you're a great question. Here's the resin costs. So these are just in Hong Kong. You could find it, but basically ABS is $1 a pound. Here's the link. You have to create a login, and it's you've got. So in general, you want to use as few resins as you can. So don't make it a rainbow of different resins, if you can. And basically for housings we use ABS. It's a good engineering grade plastic. For gears use Delrin, which is this palm. Yeah, what else? Acrylic is the PMMA for like lenses and things. Polycarbonate is also great if you need optical. And then Sanaprene is like a flexible plastic for overmolding. But yeah, try to keep it simple. And the way you'll do your parts also is you'll probably have family molds. So suppose I was just building like this Logitech clicker. It's got a top and a bottom and a clamshell. I know for every one I build, there's one top and one bottom that go together. So and they're probably the same. They ought to be the same material. So I'd put them both in the same tool. And then the shot is the sum of the two of them, so that every time I've got the right parts and they go together. And that saves time because it saves time in the cycle time, if that makes sense.
I don't remember. Did you have the mold cost?
I didn't include the mold cost, and I don't get into too much detail here, but the things that drive the mold cost, in China we use mold bases, so it's like the whole, a mold like this is probably this big, and it's got all the mechanism from the different plates and the ejector pins. And basically the things that drive the mold cost are, I always use steel molds, but is it steel or aluminum? Aluminum's a little bit cheaper, but we're not tooled up in China for that. And then is it a soft tool or a hard tool? A soft tool you'll get 50,000 shots out of roughly. A hard tool you'll get 500,000. If you're Lego, you'll get 2 million because they're really good at this stuff. And then it also depends on the number of features. So for the gear, it didn't matter from an injection plastic costing standpoint, how many features I have, don't care. But from a tooling standpoint, it absolutely does, because you've got to basically create the EDM or plunge electrodes and bang it out. So that will definitely drive your cost up. The grade of the tool, so if you're doing like an optical lens, you want a really fine grain tool steel, whereas if you're just doing some housing that's internal, you don't really care. And then the polish. So is it like a mirror spark polish because it takes longer, or have you put some texture on it?
And if you have any ballpark figures, let's say?
Yeah.
You're building an enclosure, you have two clams that's locked together?
Yeah, so this mold here, you like not knowing what's on the inside, but let's just say it's a simple clamshell out of ABS. I'd expect that'd be about a $4,000 to $5,000 tool. It's usually a quarter as a really super rough rule of thumb, a quarter the price in China compared to here. But it totally depended on the part. A top shell of something like this with a hot runner is probably $15,000, and that's a pretty big part.
How does that compare to US pricing?
Yeah, so on that, if this was $4,000, I'd bet this would be roughly a $16,000 tool in the US. And again, these are just very broadly, thinking about it for about 10 seconds, but it's probably not too far off.
4 times.
Yeah, that's usually what I figure. In the US, and I don't know too much about tooling here, but we use mud frames, so it's really just the inserts that slide in and out, whereas in China we use mold bases, so it's this whole giant chunk of steel.
So stupid question. So I'm going to come to the factory already knowing how to make and fabricate each of the parts that go into this, or are you working with it? Does the factory then say, well, we should make this out of plastic, we should make this out of metal?
Yeah, you should have a rough idea just to have an opinion going in, but they'll really help you say, all right, why don't we do these two in this family mold, use ABS with a 10% regrind or whatever, and this one needs a lens, so that's going to be polycarbonate. And a great factory should help you. One of the things that you look at as you pick a factory is their level of capability. So if this is your 100th project and you just want to build to print, they're not going to give you a lot of feedback, but you're going to pay a lower margin. Whereas we typically recommend going with a more capable factory, and maybe instead of 12% markup, you give them 15%, but you get all that knowledge. And going back to like alignment, they make money on volume, so they want the product to succeed in the market and be easy to put together. So they'll really help you. And the teams in China are amazing. Like building the plastic part is just the beginning, but when you go over there and look at all the teams laying out the molds, like that's a whole other project. And it's just, injection molding is as much an art as a science. although with mold flow, it's pretty cool. You can get some good visualization, but how do you line these up? How do you get an even pressure drop? How do you get them to eject without getting stuck? And then on all plastic parts, we have drafts and rounds, which I won't go into too much, but I'll go into a little bit. So you want a uniform wall thickness, usually 2 millimeters, where your ribs are 1.6 millimeters. And you basically, if you had straight walls on it, all plastic shrinks, so it's going to hug the tool, and it would get stuck and scratch like crazy. So think of like a Dixie cup or something. That angle is called draft. So you want to put in roughly a 1/2 degree draft on all of your walls. And then a nice round, think of plastic as like toothpaste as it goes in, so it wants to flow nicely. If you have sharp corners, you get shear and all this weird stuff. So there's a whole art to taking your parts and doing it. And with a lot of experience, you can just design the parts. Like DJ, who's in the corner there, built a couple million Roombas and Scubas and small Scubas. So like his parts are just going to be perfect and come right out. I know when I started, mine were anything but perfect. So a good factory will help you and teach you. But yeah, there's a lot to injection molding.
How much does the technology for the case affect the factory? Like if you said you wanted a metal case versus a plastic case, would you be looking at different factories, or would you expect one to be able to cover the...
Yeah, so you'd want to look at the, it's a great question, the spectrum. If I had a mix of some plastic and some metal, I'd probably outsource the die cast metal. So a good example is on the first Scuba, we had this awesome metal handle. It was just die cast and it had 3 different coatings on it. That we just outsourced to the metal factory and brought that in. If the part was all metal, I'd probably pick a different factory that had that in-house. So the trick is, and the reason why you always want to have your SMT, and SMT is putting the components on the board in-house, is every time something comes in, they're going to charge that 15% markup. Whereas if they do it in-house, you can, everything they touch will hit the 15%, but then the other factory is going to charge you 15%, so you get hit twice. So you'd want to think, if it's all metal, pick a factory that does whatever that technology is. But if it's a hybrid, then you'll probably just take the hit of bringing it in. And often the markup for like the die casting factory is probably not 15%, maybe it's 8%, so it won't be quite as bad. But yeah, usually you want to pick like factories that have stuff that are similar. So I remember looking for the Roomba, like we go on this great factory tour and then look in their showroom and they'd have like a stapler and be like, we've built a stapler. It's like, no, you just don't get it. So pick something that's similar.
If you do hard tooling but you don't wear it out and then end up ramping up with another factory, do you ever have an issue getting the tooling moved from one factory to another?
Oh, absolutely. Yeah, I mean, in theory, it seems like it should be easy to move, but the thing is the first factory is not going to want to give up the business, and probably the relationship is deteriorated, so it's going to be really difficult. I always assume we're just going to have to make new tools. It is possible to move it, but then the new factory is probably going to have trouble running it for whatever reason. They just never seem to be able to run old tools. So we've seen that play out time and time again, which is why it's so important to pick the right factory up front and look at them with your own eyes and feet and just have a dialogue with them. And if they're just a pain in the butt, then it's, like that's a good day that you're giving them business. You know that bad day is going to come and they're going to be a nightmare. So that's resin. These are the molding costs. And we can find a way to share this. These are just by experience. But yeah, so this part here is probably like an 80-ton press. 280-ton press is pretty big. And to give you an idea, like a 1,000-ton press is as big as a locomotive. It's amazing to see, and that would do like a deck chair. So let's see. So I'll move along quickly because I think I'm taking too long. Electrical is super easy, just the usage, the quantity times the price. We talked about separating the expensive components and then applying the markup. So those are pretty straightforward. These are the standard markups. So if you're just building bare boards, this is what it is. Toys usually have a lower quality, so they don't take as many fixtures. Consumer goods is what we build, maybe 15 to 20%. If you have a great factory you really like and you want to get in, you might give them 20% just to get in. But it should be 15, and then medical can go anywhere. The markups are insane, but there's different constraints.
Do those, how steady do they say volume goes up? The markup?
Those are pretty, those typically hold pretty steady. If you were, so most factories want to build a minimum of 5,000 units. And again, I'm just speaking of China. Well, at least to get in the door. I mean, they're all hopeful it's going to be the next GoPro, and that's what the factories are like. VCs, they have limited resources, and you want to get them excited about your project, so they invest from an opportunity standpoint. But yeah, in the minimum, the 5,000 units comes from the MLQ. So like if I wanted to drink 5 beers, which would be awesome, I can't buy 5 beers, or I'm going to pay a lot more. I'm going to have to buy a 6-pack, and then I have 1 left over. And that leftover beer I would drink anyhow, but it would be otherwise amortized into the cost of the 5 beers. So if you wanted to build like 1,000 units, you still have to buy 5,000. So that's where you think about the manufacturing strategy. And then other things, you've got to pay for the tampo. It's pretty cheap, but spray painting can be super expensive. Labor, don't forget the packaging. The way packaging works is you've got the blister pack, or the gift box as we call it, which might be a 4-color printed thing. And then you can't put, like however small the package is here, I'm not going to put 100,000 of these in a 40-foot HQ container, because it's going to be a giant nightmare. So I'd put these probably 100 in a what's called a master carton, which is sort of that ugly cardboard box, and then I fit the cardboard boxes in. But you've got to pay for that, so don't forget that. And then this is just one of our Dragon bombs, and of course you can't read it, but what's going on is on the top row is calculating the price of the plastic injection molded parts, starting from the piece and then building up the family mold, and then the and basically, I should say, what we do here is we have the factories fill in the yellow blocks, so that I have a apples to apples bomb I can use to compare my factories. Otherwise, they'll give you every which thing. And then it's just purchase parts, electrical components, blah, blah, blah. It sums up down here, and then you can see. But it's exactly what I talked about before. Yeah, and this is the order of what's going on in there. So that's the, oh, awesome.
Is there any simple rule of thumb to go from concept prototype to finished product?
Not that I've found. The electronics typically drive most of the cost. So if you can get a rough idea of what those costs, and maybe you can apply a scaling factor. But every product is so, yeah, we don't have a rule of thumb. And the thing is, like, the cost is so important to the business that we always want to dive in. The one thing I'll say though, and it's a mistake we used to make all the time, is the cost of goods sold and the retail price are 2 totally different things. So the rule of thumb is going from retail price to cost of goods sold for a consumer electronic. Use a rule of 4. So if you buy it for 100, the cost of goods better be 25 bucks or lower. But you can't go the other way, and that's the key thing to remember. You can't say this cost me 25 bucks, I should sell it for 100, because you might be able to sell it for 500. You don't know what the value is, or you might be able to sell it for 10. So it only goes one way, is like, and it also assumes it's not a razor blade model, or not something where you have a cloud service and you're selling that subscription. So for this, I'll speed it along, but I wanted to spend the most time on costing, because it's the thing you can most easily sink your teeth into. Does anybody know who this guy is? Yeah, so it's a few years old, but this is a guy who is the head of Toyota when there's all the challenges with their quality. So you don't want to be that guy. He was having a bad day. Quality is totally not sexy, but when you need it, it's going to be super important, and you want to bake it in from the beginning. I know when we first started, we were just excited to get one working and then build a lot of them. And that's it's hard to do, but in the scale of things versus building a quality product, quality is super, super hard to get right, and it's super expensive if you screw it up. So I'm not going to go too deep into it, but please keep in mind it's really important. So a few quick definitions, like being engineers, how do you define quality? So here's a simple formula. That it's customer satisfaction, and that's the performance minus expectations. So everything is different. Like, you don't want to build a Rolex if people don't need that level of quality, because it's going to be way too expensive. That's not what we're trying to do here, but you want to match the quality with the application. And then fitness for use is another super simple one. I'm just going to zing through these, and we'll pick a few of them. The question is, do I have one more? Yes. Okay. So things to keep in mind are some of the different types of quality. There's a lot of ways you can do it. One is just functional. Does the thing do what it's supposed to do at a very basic level? And you should always have that. You can also do things like a built-in test. So if you've got sensors, listen to them. If you've got actuators, actuate them, just to make sure that it works and hangs together. You can do abuse testing. So we talk about tension torque. So we would literally have vice grips with a fish scale on it, and pulling, you want to have about 20 pounds or 21 pounds on everything that you can grab without it breaking. And I forget what we apply for torque, but twist it so that it doesn't break. Everything will survive a drop test.
Are you testing off the line or for your prototype?
Both. Yeah, it depends on what stage you are. Like functional tests would definitely be the prototype, and then I would put everything through, I'd say like a 600% functional test, and then I test it at different stages. So, and I'll just pick the Roomba because everybody knows about it. Like we would test the bare board to make sure that worked, then we'd put it in the robot with the lid off and test that to make sure it worked. Then we put the lid on and make sure it worked, and then we'd run it around. So the last thing in the world you want to do is build the whole thing and test it, but you want to test it on a modular level in stages so that you can rework it.
And where in your BOM does that show up as cost?
Yeah, so it shows up in two places. One is mostly in the margin, and also in the labor. So if you are, like we use these AQL levels, which just are for a final inspection, how good we want the product. If you have super tight, like a super tight net, they're probably going to charge you more in terms of the margins. You also may get a little fixed cost on the test fixtures, depending on how you do that. But yeah, quality is super important. The best thing, I guess, and I can go on for a lot, but I'll just move so we can get to the questions, is just get your hands dirty. So the last thing you want to do is, like, again, I always go back to China. It's a long way away. It's a different time zone. It's different language, different culture. It's impossible to build a good product if you're not over there. So, and that's sort of what Dragon does, is we're over there, so you don't have to be. But in the absence of that, like, get on a plane, go over there and walk around and get your hands dirty. Like, this stuff it can be complex, but it's not rocket science. So just by having feet in the ground, looking at it, you'll be able to debug a lot of things and close the loop locally, as opposed to trying to take a late night phone call and when it's hard to understand and try to debug it that way. That's like just to boil this thing down, one of the most important things to do. And the ultimate thing, and I think I've got it at the bottom, is at the end of the day, you just want to be able to answer, is the product good? So imagine you've been building this thing and you've got 100,000 of them sitting on the loading dock, which cost a couple $1 million in COGS. And you just have to say, do I accept it or do I reject it? It's a simple question. So just be able to answer that and you'll be in good shape. All right, no problem. So schedule. So the third part of our triangle is many things in the consumer electronic world are driven by the holiday season, and unfortunately it has a fixed date. You cannot move Christmas. And the way the sales go, and I think I've got it on this picture here, is that this is Black Friday, last day or day after Thanksgiving, working up to Christmas. If you're late, you lose the long bar, which is where all your revenue is, and that doesn't come back because that curve is going to drop to zero. So you absolutely, and I've Daniel, who's here, who did all the software for the first Roomba and also helped me build my real baby. Like, we were late on the baby and we lost a tremendous number of sales because of it. So we got that lesson drilled into us, but don't be late. So the way you avoid being late is you have contingency, and we all know that things take longer than we ever planned. So build that in. Again, be on site because you can close the loop a lot more quickly. Take corrective actions early and often. Like, things rarely get better. They need outside force to get them on track. So be really aggressive with that, and then just get them right the first time. So it's all stuff you know, but just you take the schedule super seriously. This is a little bit old, but the milestones are the same. So just sort of walking around, we go from prototypes to the vendor quote package and handover. So basically transferring your knowledge to the factory. You do the design for manufacture and assembly, so adding the drafts and rounds and that good stuff. You do tool start, where you hand over the files, and then this whole process of creating these tools happens. Then you get the first shot, which is like the first plastic out of the tool, and that's a really big day to actually watch it come out warm in your hands and hold it. Like, it's like your old prototypes were, maybe $1,000, and now you've got this same thing that's much better. It's real and it's 25 cents, and if you don't like it, you throw it away and grab the next one. So it's like a total everything changes. Often what happens is you get a short shot so the part doesn't fill completely for whatever reason. Like it may not be pretty, it might have burn marks. You get some really cool tie-dye effects because they'll use like junk resin that's probably all different colors, so you get some good swirly things. And then it just goes into engineering pilot 1, where you sort of put it together and put the boards in, but it probably doesn't work very well. And then the real one is engineering pilot 2, which is, or EP2, which is actually where you have a usable product, and then you can do your customer use testing. So on those, you might want to build 200 of them and get them out in the world and see what people think. Then final engineering pilot is a product that's saleable. It's just put together by a team of skilled engineers. So it's not it's not off the line, but it is what the final thing should look like. PP is production pilot, which is where you ramp up the line. And then PS is production start, which is a huge day. And then this is first onboard ship, where you send it over. So, and this is a lot of stuff, which I won't go through in great detail, but just keep in mind there's a lot of stuff that happens. So it goes on, and once you've got it rolling, then you often go into sustaining engineering, so getting the quality up and the cost down. And that's its own bailiwick, because you're probably using the tools to shoot the parts, but then you have to take the tools out to make changes to them, and then how do you deal with that? And it's its own project. So anyhow, that's kind of the background. Oh, please.
What is Sunset?
Sunset's finishing up the project, like eventually stopping the project and hopefully working on the next one. So ending that version and then, putting it to bed.
Well, between the different engineering pilots, how much change, what kind of change? Did you change molds, did you change circuit boards, what did you change?
Yeah, so what should happen ideally is before you start the tooling, you've got a functional prototype that works exactly as you want it to. Now, this never happens, but that's always the goal, and everybody always says, next time we're going to do that. So what you're typically changing is often the parts won't line up very well, or in some cases, the functions won't work quite as well as you want, or the buttons won't feel right. So ideally, it's just those little tweaks. There's this idea in tooling called steel-safe design. So if I had a snap fit, just like an arm that goes in, you can always add plastic because you're machining away metal, but it's a pain in the butt to add metal because you have to get out the welder and build up the metal and then machine it away. So we typically design things that are a sloppy fit with the idea that we can add plastic later. So you're probably going through and touching that. Like the design tools now are so good, and with EDM machining, it's so good that you can almost get it right the first time. But it's ideally just little things like that. We've also seen things that are much worse where the thing just doesn't work, and we have to fundamentally change it, which we try to avoid.
What's the minimum volume for which you recommend manufacturing in China, like for a hybrid product?
Yeah, so for most products, our general guideline is 5,000 units. And kind of the way we think about it is that if it's less than 1,000, you could do it on your dining room table. It's not going to be fun. People are going to be cranky, but you could bang it out. The worst part is 1,000 to 5,000, because most China vendors aren't going to want to deal with it. And it's just frankly a lot of work to deal with China for something like that. It's much better to be next to the CM and say, hey, I wanted to do this and do that, speak in English, and have it a short drive away. So there are some great US CMs that can help with that. One area where we're really excited, and it's not there yet, but if you're only going to build 3,000 units, you don't really want to build tools, but you also don't want to pay CNC prices. And our hope, and I don't know if it'll get there, but if we can get 3D printing good enough so that it's basically isotropic, so that it's the same in it's basically an injection molded part that you can 3D print, I would pay like 5 times as much for one of those parts to avoid tooling, because tooling is like 8 weeks and then you got to debug the thing. So that's an area that I get really excited about.
Would you ever do a pilot run at a different manufacturer for the, speak in English and have it a short drive away? Say if you want a few hundred for market testing?
Right. So there's basically 3 strategies, broadly speaking, 3 strategies you could do. You could build low volume in China and then deal with the headache and try to scale it up. You could build low volume in the US and then sort of accept the higher prices. Or you could do the hybrid model. And the challenge with the hybrid model is that you're probably going to need to buy another set of tools because it's hard to ship. It's not impossible, but to move the tools. And what I find is you lose the domain knowledge. So the factory learned so much in building this that's captured in their heads. And then to start all over again, you've got that. And it also disrupts your supply chain. So if you start here and it's a huge hit, it's probably easier just to continue to build it here rather than have to stop and potentially lose all that business.
Have you ever worked with any of the CMs that manage that transition? You know, have both, like Mac or Sanmina or any of those?
Yeah, I think it exists, but I haven't seen it in my experience.
Okay.
And we're getting more and more into the US because of that local close the loop, and we're really into crowdfunding, and I see on the horizon that 1,000 to 5,000 units is going to be a lot of volume in that low volume area, so it's a problem we have to solve. But we haven't cracked that nut yet. Oh, the question was, have we seen the hybrid approach in practice of starting here and then moving?
So if you do have a component failure, an electronic component failure, how do you go about having a conversation with the factory to determine if it's like a systemic problem or a one-off?
Yeah, okay, so the question is, if you have an electronic component failure, how do you sort it out in terms of is it one-off or not? So key thing is having I would say, feet on the ground wherever your factory is to get the data, because it's always sort of like the fog of war, like it's confusing as to what went wrong, and it could be many things. And then ideally, you'll of course have a good quality plan to test for it, and multiple samples. So a lot depends on the failure mode, and everything is always shades of gray. Like it's very rare it's just a design problem or just a manufacturing problem. It's always something in the middle. With a good manufacturing service agreement, you can try to anticipate these things and lay it out ahead of time, so you can use that as a guideline for what happens. So in the case of a catastrophic failure, like 100% of them fail, then that should be covered. Usually we say like if more than 3% of them fail, the factory has to absorb the complete cost for fixing it if it's a manufacturing defect. But yeah, step one, get the data and understand it. And then there's good strategies like the 8-step plan to go and be able to correct it. But it's almost like everyone is a unique situation. And there's different categories of failures. The best failure in the world is one that affects 100% of the units at 0 hours. The worst one, which we've seen and cost us many days of sleep, is the one that happens after 40 hours in 1% of the units, because it's just super hard to fix. And Daniel, who's in here, solved a mechanical problem in software, doing that, saving us reworking. We still had to rework 50,000 Roombas, which is more Roombas than would fit in here. But it was one of those failures, like the intermittent after time. They're a nightmare. But you do see really weird stuff. Like we see a lot of multi-layer capacitors crack, and you get a low current leak or things like that, which are just sort of a bear. Yes, but quality is a really big deal.
Okay, well, let's say you delegate the design of your enclosure and molding, etc., to the factory. Now, who owns the IP for the enclosure design? And tied to that question, would it be possible to find something that matches what you're looking for? There's all these generic products with generic enclosures, which would probably fit your needs, and most of the time it's not always necessary to design and build your own.
Right. Okay, so the first question was, if you have a factory design and enclosure, who owns the IP? And what you want to do there is always pay a little bit of NRE so that it's clear that you own the IP, because if you want to change factories or anything like that, so you're not held hostage, and it also lets you push them to go faster. And then in terms of if you can buy like a bud box or an enclosure itself, for low volume it probably makes sense to do that. For high volume, I always build my own thing, just because I can get it exactly as I want it. And design is so important these days that it's probably not, I mean, if it's just something stuck inside, then maybe it doesn't matter, or if it's a business-to-business application. But most of what we do is consumer, and it's very design-focused, that I probably want to just build it myself. And again, like the tooling here is probably $4,000, so it depends on how big you go.
And can you get these plastic parts milled? Let's say you want, let's say USB socket or whatever.
Yeah, you can definitely CNC things. So a great example is like the iPad case. Like that's just extruded aluminum that they hog out. So you can do that, and what drives the cost there is just the price of the material, and then the labor rate and the overhead of the machine. So how long does it take to go? How much does the operator cost? How much does the electricity cost and the maintenance? So it's all things that you can definitely figure out. And we have different formulas, for extrusion, milling, and so on. But sort of the same approach to injection molding, we would just take to that.
So we're just about at 8. Do we
Okay.
want to try to do some interactive?
Yes. Yep, that's awesome. I think, and so what we wanted to set you up is why it matters is that product development is fundamentally changing. So in the old days, we used to build and then try to sell. These days, we see it's a lot better to sell and then build. But to be successful, you have to understand the stuff up front, because if you don't, you'll get killed. You won't raise enough money or things like that. Whereas in the old days, because you built it first, you already understand it. So it'd be less of a risk. So if you're thinking of crowdfunding, it does all these awesome things up front so that you're not risking your capital before you actually build it. And it's just important to get the math right up front. So hopefully this is useful on that front. And then what we're working on, and Dragon, I'll just put a plug for that, is we've stood up a hardware-only crowdfunding platform, really with the tools that hardware entrepreneurs need to go and succeed. And we do all this stuff basically as part of our service for free, so no cost to you, so that we can make sure that you succeed in your crowdfunding campaign. And yeah, that's it.
So do we want to try to do some audience?
Okay, so we're actually going to put this to a vote. We had said that Scott would be here to help you guys with projects that you're actually working on right now. Raise your hand if you've got a project that you'd like to talk to Scott about. Okay. For those of you who'd like to get up and stretch, feel free. For those rest of us who would like to hear some hands-on help, I'm going to take it. I'll take the mic to you, so raise your hand, and then you can ask Scott a question.
Hi, I'm Jamie, and I am trying to do something that's not necessarily a technological innovation, it's just really interior design for small spaces. So I'm trying to create a way to beautify cubicles. What that entails are bulletin boards, a way to wrap a wall, but I have very crude prototypes that I've done myself. So I'm looking for help in, one, where do I go to prototype those things professionally? And two, are there good small-scale manufacturers I can use for office supplies?
Right. Cool. It sounds like a really interesting project. So for what you're doing, I'd expect building locally would be a lot easier than having the hassle of dealing far away. There's a great resource. His name is Dave Latore, and he was actually the project manager for all of Brookstones for a while, like building the cool stuff. And he started this thing, I think it's called Project 100. If you shoot me an email, it's just Scott at dragoninnovation.com. I'll connect you with Dave, and he's got this amazing network of local CMs in 100 miles of Worcester that cover everything from material to leather to metal and so on. So he's probably a great resource to get you connected.
Thank you.
Oh, of course, good luck.
I'm Molly, and I'm making a scale for people in wheelchairs to weigh themselves at home. So it's a really big 4 feet by 4 feet hardware piece of thing. And basically we have a big metal part and some small plastic parts and then some PCBs. And my question is, would those, let's say we do volumes between 1,000 and 5,000 we do in the US, would those be in different factories, or would it make sense to do them at the same factory? Who does assembly? What does that look like?
Right, so you would probably do the plastic and the final assembly. Well, let's see, to think about how they think about the US a little. You said I guess it would depend more on if you're on the 1,000 side or the 5,000 and your ability to set up your own shop. One way you might approach it is having you be the final assembly. So shooting the plastic, doing the boards, and bending the metal, and then assembling it yourself if it's on the 1,000 side. If it's on the 5,000 side, then you probably want to find a factory to do the final assembly. And in general, I guess the way I would approach it is try to get the plastic factory to do the assembly. The metal ones are usually a little bit lower on the ecosystem, like they're just going to shoot the metal, or they're going to bend the metal, but they're not going to do much else. And the board houses typically they'll do boards, but the plastic, you could probably talk them into setting up a little area and then doing it. And then you just want a really good quality plan. So, that might involve incoming quality control where you measure, do functional tests on the board, or you could also do outgoing quality control from the board house, then IQC, and then put it together and test it and so on. But I bet there'd be a lot of hands-on stuff. And the great thing is, you're bringing your product to life, and you learn so much by doing it yourself. Just, figure out where the pain is and where things go smoothly.
Anyone else have projects?
Thank you. John Martell. I'm with a small product development company, and we have an audio product coming to Best Buy nationally in a month. So we're excited. But one thing I haven't thought much about is knockoffs. If we have success, how do you stop those?
Right, so knockoffs are tough. The best way that we've seen is to protect your software by consigning a thing if you've got software in it that differentiates it. And the great thing today is everything's connected, so if you control the cloud side, you can pretty much protect your hardware. For something that you can't protect the software, then the most important thing is picking a great factory. Are you building in the US or building in China or someplace else?
I'm not sure where that's been decided, but I'm assuming it's overseas. We just
Overseas. Okay.
developed in Korea.
Korea. Okay, so yeah, always go back to picking a great factory that you trust. Where you're going to get leaks is, think of the factory, there's 3 different levels. You've got the bosses, you've got the engineers, and you've got the workers. In general, and it depends what you're worried about in terms of a knockoff. The bosses aren't going to let it out because they're going to lose business, and if it's found out that they lost a project, nobody else is going to work with them. Often the workers don't know enough or don't have exposure enough to the material, so that the worst they could do is give a sample to a competitor, but by that time you're already in the market and it's less of a problem. The one you often have to worry about is the sort of the engineering level that might make $200 a month, and somebody can approach them and say, here's $1,000 for this thumb drive, and it gets really tricky on a cultural level, which I'm not going to get into, but it's possible that your design could leak out. So you always want to practice good IP hygiene, so never leave stuff lying around, leave your computer locked, and then a need-to-know basis, so only give the files to as few people as you can. I know when we did the Roomba, we had a knockoff in the market 6 weeks after we launched, and the funny thing is tooling takes 8 weeks, so it didn't work. Fortunately, they got the resins wrong and it died, but there's no functioning legal system in China, so it's, and you don't really want to sue anybody. That's not going to work. If there's any software you can protect, that's always the best way to do it. But otherwise, just have a great factory and just practice good hygiene. Everybody hears all these stories of that, and it can be really tricky to protect. Yeah, and also I'd just say it's not necessarily just China, it could be anywhere.
Are patents a protection against that knockoffs?
They may be, as it comes into the US, you might be able to protect it that way. We like to get earlier just to make it so it's harder to knock off. And one of the things we like to do is work with factories that are very well connected with the central government. And that way, if you do have a problem, like China's really uptight about counterfeit goods because they're a member of the WTO, and it's bad for them. So you can say, hey, this factory is knocking us off, and the government might be able to help you.
Hi, American Lincoln, also an adjunct in Olin, so this might be a lunchtime conversation. We have a product that's 90% technically done and negative 10% human done. How does a group of engineers adopt the human side of this process quickly?
Interesting. So do you have to, do you want to build additional samples, like to get 10 of them for a customer use test? Or tell me a little bit more about the human side.
So we have Rev 4 hardware. It works beautifully. It's on our desks. It does everything we want to and more, but it does everything that we want it to do. It does things in our desks, and we're engineers staring at our feet. So how do we get into the real world?
Cool. The way I would look at it there, and I'm definitely really excited about crowdfunding these days, is to think about putting it on a platform. Of course, we'd love to have it on Dragon, but more broadly speaking, what crowdfunding does is it lets you validate the product before you actually spend time building it up in volume. You also understand what inventory levels you need to build to. Is it 500, 5,000, or so on? Create a really efficient community that will go spread the word. And if they like it, you can ask them questions like, these are the 4 features we're thinking about, how would you rate them? And get them in the co-creation process. So it's almost like you could think of it sitting at the chef's table at Les Pellier, watching Frank McClellan prepare your meal. Like, it's pretty cool to see that unfold in front of you. And also a farmer's market, giving people the ability to talk to you and say, how are your carrots different from Stop and Shops? And why did you do this and do that? So we love the idea of community involvement and moving all the risk up. So the story I'll use there is for Roomba, we paid maybe $10 million to build the thing, $3 million on marketing, just picking rough numbers, and people loved it, and I literally couldn't build them fast enough for 2 years. And we did exactly the same thing on Scuba, figuring it worked once, it's what you do, and nobody came to the party because a mop and bucket cost $10 and a Scuba cost $400. And it would have been nice to know that 3 years earlier with $13 million more in our pocket. So, product development is super hard, and it's really difficult. It's exactly the problem you're bringing up. Like, for engineers looking at something, it looks awesome, but how are people going to react to it in the real world? So just moving that risk up front, I get really excited about crowdfunding to be able to do that. Oh, of course.
Great topic. It's directly related to what we're doing. I'm the founder of a company called Vicarious, and we're developing a device that recovers exhaust waste heat from vehicles. You can insert it right into the exhaust pipe stream and converts exhaust waste heat into electricity. And we've the design is such that it's cheap enough that it's similar to like a consumer product, and we expect to be selling this to the mass markets, tens of hundreds of thousands. But we're very early stage, and so a company like us, a lot of startups, I'm sure, face this. You get maybe a good first cut of something like this. We don't of this type of approach, DFMA. Where might we go, like as a consultant, expert, to do that? You might provide the services, maybe not. Where would we go for that kind of first cut, that sort of thing, and what level? That's my first question. And then we're doing, actually, almost everything a part of our unit is all sheet metal, but there's sheet metal forms and bends and that sort of thing. So I'm not sure if your answer would change relative to that.
Yeah, cool. It sounds like an awesome product. I haven't seen anything else out there like that, so definitely looking forward to learning more. A few ideas is we love this stuff at Dragon, so we can always sit down with you and just brainstorm and help out in any way we can. Bolt is amazing where you are here, so depending on what your interests are, this might be a really awesome opportunity for that. And also, for the full disclosure, I'm a GP at Bolt, so I'm lucky that I get to work with Ben and Axel and a great team here. But that's basically what we're tooled up for. And then in terms of additional resources, that's sort of the challenge, is that a lot of the stuff you just can't Google. It's all experience-based or just talking to the right people. I'd say it'd probably be good to sit down and brainstorm, and then we can try to connect you with people. And there are also. That's what I love about our business, is that this stuff isn't it's not widely known. So anything we can help to shed light on it, we're totally happy to do.
For startups, gain an early read on that ballpark pricing and that sort of thing, really, you know, affects where you go for markets and that sort of thing, so.
Yeah.
that's why
Yep, and for the
it would be helpful.
costing for the sheet metal, you know, the way I'd start on that is figure out what sheet metal costs, and for that, figure out what aluminum costs. I think it's about $1 a pound, and it's a commodity, so it goes up and down. And then figure out how much weight do you need, and then you could figure out, you could probably take a guess, like maybe it costs $50 an hour to operate a 300-ton press, and maybe it's one whack every 10 seconds, and just do some rough, and we could help you tighten it up, but that's the way I would start to approach it.
Yeah, we've done a first prototype, and now I have funding to build a full prototype and all that. So anybody that's interested in joining our team, we are hiring for mechanical engineers in this area. So feel free to come up to me afterwards here. My name is Steve Casey.
Cool. Oh, and one other resource, Steve, there's a great book by Boothroyd Dewhurst. I think they're out of Rhode Island, and I think it's called DFMA, and it's dfma.com. And that's a great thing to describe the different processes to go through.
Great, thank you.
Okay, we'll do maybe just one more, and we'll go back there.
Hi, I'm Reed Turkman. I'm a college sophomore at Batson, so I know Owen very well. I'm in the very beginning stages of a kind of high industry business, or not high industry, high mechanical machines, business-to-business product. And I just wondered if there's any big differences between the consumer electronics, kind of building a prototype that I'd be able to bring to one of these larger businesses that could then help me fund and then push my idea forward. Are there any dramatic differences between the consumer electronics or more big industrial machines? That's only part of it, and there's a large IT part of it too. But as far as just getting a prototype to then go in front of a business and have obviously a plan, is there any big differences that you discover?
Yeah, that's a great question. So one of the big things is just thinking about cost, quality, and schedule. Usually the quality, like in consumer electronics, we're super concerned about all three. But as you get to B2B, you know, probably price is less sensitive, that they can afford a bigger budget. So you could improve quality, and schedule probably doesn't matter as much. At least it's not on a calendar thing. It's maybe more in their budgeting cycles.
Would you say it would be behoove me to possibly go and talk to any of these businesses before I even have a working prototype to see if they would possibly work with me to develop the software and I guess get a partner early in the process?
Yeah, I love the idea of trying things out ahead of time. Just what we see all the time is engineers get excited about something and build technology, you know, sort of in looking for a market. But I think the more you can talk to people and figure out where the market is and what their pain point is, and then create a solution that addresses that, it's a much better, more efficient approach.
Thank you.
Oh, cool.
This was
Thank
awesome.
you.
And I just want to thank you guys for being such an engaged audience. This is what makes it really fun. So, Scott, thank you for taking the time, and I want to say a huge thanks to Bolt as well for this amazing space. So, I encourage you to talk, mix, mingle, and thanks for attending Hack Boston.
Thank you.